Finally, to characterize this catastrophe phenomenon, let's look at the location of the fixed points as a function of our control parameter. So let's plot again as a function of our control parameter, which is h, the values of x star. So what we saw is that if h was larger than plus hc, then we had a stable fixed point at a positive value of x. So let me try and represent that as follows. So it's a fixed point like this. And this stable fixed point continues to persist even when h passes through hc, but this fixed point remains until they reach minus hc, at which point the fixed point for positive values of x just kisses the x-axis and then suddenly disappears. So at minus hc, there's no longer a fixed point at positive values of x star. Similarly, if I'm coming from the negative direction, if I have h very negative, then we see that there was one fixed point at a negative value of x, and this fixed point continues to persist until they reach positive hc, at which point the fixed point disappears. In between these two fixed points is the unstable fixed point. When we pass below hc, then fixed points are born at negative values of x, and so there's another fixed point that's born like so, and so this is the unstable fixed point, whereas these are the stable fixed points. And this type of a diagram is actually the beginnings of understanding the phenomenon of hysteresis, because let's imagine that we start with h very large and we're sitting at a stable fixed point of the dynamics. And so as we start for a large value of h, and suppose that somehow our control parameter is decreasing, I run along the stable fixed point, and then at some point h decreases beyond minus hc, there's no longer a fixed point here, and basically what happens is that I suddenly drop to the negative fixed point. And then if I imagine starting for very negative values of x, and increasing h, then I run along the stable fixed point for negative x until I run out of fixed point, and then suddenly I have to jump to the other type of stable fixed point. As I decrease h, I reach a point where I suddenly have to drop to the other solution, and when I increase h, I have to go beyond the point where I drop down to get back up to the other solution. So this is ultimately underlying the phenomenon of hysteresis that we'll encounter in other examples later in this course.